hydraulic mean depth, that is M. This is also characteristic dimension for duct because if we choose duct is circular, then D is what? Hydraulic mean depth, that is DH, sorry, M. If we choose circular dimension, if we choose rectangular dimension, if we choose oval shape, how we calculate, how we can convert this D? Because for rectangular shape, D is not valid. So that is why we will go for our characteristic dimension, that is M. Okay, characteristic dimension, that is M. M is uh, equivalent dimension for all types of duct. M is called cross-sectional cross-sectional area, capital A, by weighted perimeter of duct, that is P. That means M is called A by P. For circular diameter, what is M? Characteristic dimension of circular diameter area is pi by 4 d square. D here, D is diameter and perimeter is pi d. That is pi cancel out, d cancel out. That is d by 4 for circular diameter. In case of rectangular, how we calculate? Rectangular is A, suppose this is A, this is B, this is D. A plus A into B by 2A plus B, because perimeter of the rectangle is 2 into A plus B. That is okay. Now, friction factor is a function of Reynolds number. We already know friction factor is a function of Reynolds number. Reynolds number is rho Vt by mu, and roughness of duct. Friction factor is a function of Reynolds number and roughness of the duct, that is calculated by epsilon by d. Epsilon means absolute roughness. Okay. Generally, friction factor is calculated by some empirical relation. There are some empirical relation. There are some relations between all these formulas. First of all, for laminar case, if the flow of air in the duct is laminar, then the friction factor is 64 by Re. When Re less than 2000, we already know that is laminar. Turbulent case, turbulent friction, if the flow is turbulent, then friction factor is 0.3164 by Re. 0.3164 by Re to the power 0.25. Okay. Another one is friction factor is calculated by one chart, that is called Moody chart. Okay, where friction factor is calculated. Okay, I'm giving some small brief of Moody chart. Moody chart. How Moody chart look like this? Suppose this is chart. Moody chart. This is here is the friction factor F in terms of mm of water. Of water per meter. Here. And here is air flow. That is meter cube per second in this direction. Okay. Now, first of all, draw airflow chart. This is this all of these lines are airflow, my flow rate of air in terms of meter cube per second. All these lines, okay, black lines, and this line is friction factor in terms of of water per meter, per unit of length. Okay, this is friction factor. Now, this line is red line. The red line are inclined red lines are that is velocity. Velocity line. Okay. Or from this corner to this corner, velocity increases. From here velocity is 2 meter per second. Here is 100 meter per second. That is the concept. Okay. Another line is that is there. This green line is called diameter of duct. Diameter of duct. Okay. This is our Moody spreading curve. If we know air flow rate, that means Q. If we know velocity, if we know diameter, then we calculate the friction factor. Just simply just air velocity line, sorry, air flow line, velocity line, and diameter line where intersect. That point plotted vertically downward direction. This is the friction factor of that point. Okay. Suppose air velocity is 20 meter cube per second. Air flow or velocity is 10 meter per second and diameter is 10 meter. For this case, what is the value of friction factor? We simply directly calculated from Moody spreading curve. Simply mark the 20 meter cube per second line. Suppose this is 20 meter per cube second line. So this point is 20 meter cube per second line. Suppose this. And 10 meter per second, this is the red lines are velocity. Suppose this is 10 meter per second line. Okay, and that diameter of the duct is green line. Suppose this is 10 meter. Okay, this is 20 meter cube per second line. This is 10 meter per second, and this is 10 meter. So the intersecting point of these three lines, we locate this point. Okay, here. Now simply draw the vertical line from here to on the friction factor line. That is this point. At this given condition, this is our friction factor, standard friction factor. This is called Moody spreading curve. From this curve, we get all the dimensions. Okay. Now, next one is very important.